I saw it. I don't know whose it was.
Our unit 3 test is already in October 29th. It's 15 multiple choice and 2 I wrote a novel today. I wrote so much.
Okay. So 3-1. Strength, direction, linear relationship, correlation coefficient are correlation. Good with all that, right? This question, you knuckleheads, 22% of y'all got it correct the first try. Careful. Cause. So we for sure know it's a no. Now it was a probably not as opposed to the no, but so hopefully you put no the first time, but it's never a yes or a probably or a, because it was not an experiment. Please be careful of that. They'll do that throughout the year. They'll try to show cause and effect throughout the year. Okay. This one is probably the most missed, or it has been out of both classes, and I completely understand. This is more of today's lesson than whatever that was. What Friday? Whatever. Okay. So let's talk a little bit about it today because that will somewhat set us up. We can see from this scatter plot right here that that's somewhat the trend of the data. Okay. We're going to talk about that line of best fit today. And so if I try to draw a line of best fit, it's going to somewhat come close to those points. When you draw a line of best fit, you're trying to hit as many points as you can. And if you can't hit them, you're trying to get as close to many points as you can. Okay, that's what you're trying to do. So we got that line that somewhat goes through there. Well, they asked, what effect does hot dog brand with the smallest calorie? Well, that smallest calorie has a pretty significant effect because with that line of data, that point's way, way down there. And so what that's going to do is pull that line down closer to that point. Not all the way towards it, but it's going to pull it quite a bit. Okay? So again, that's more of today's lesson than really what you needed to know for this one. I really believe that after today, you will be able to answer that one better. Okay? So they'll do that sometimes to set you up for the next lesson, and that's kind of what they were doing with that question. You'll see one tonight also. Okay? All right. Everybody okay with correlation and least squares, or not? Nah, that's today, sorry. Correlation and line of best, what was it? Oh, describing the line, right? Give me a direction, give me the strength of it, and then tell me it's linear or curved. And then always put it in context. So we're going to do 3.2 part of it today. We'll finish 3.2 later. Some of you guys are looking ahead to your notes already, and y'all are really realizing that something special about 3.3. There is a 3.3, there's just no notes. Okay, 3.2. I mentioned this chapter really, it's the only time we're going to deal with bivariate data. It's the only time we're going to deal with bivariate data, okay? A lot of definitions that are in this chapter, a lot of interpretations. Interpretation, the correlation right now is all we need, all we know, okay? All right, we know that we don't know, we assume there's going to be a relationship between the two variables, the x variable and the y variable. We assume there's a relationship. Sometimes it's curved, sometimes it's linear, and sometimes there's not one, right? After we plot the data, we want to see how well it correlates. Is it strong? Is it moderate? Is it weak? Okay. If it's strong, how strong is it? And can we draw conclusions from that? If it's weak, is it giving us good enough information? Okay, so all that stuff. If it correlates well enough, we want to use that data to make predictions. All this stuff, guys, take that for what it's worth. This is kind of, So here's what you need to know, regression line, okay? That is my line of best fit. The regression line is the line of best fit. You guys may recognize regression from those of you that did pre-cal a couple of years ago, because we did linear regression, we did exponential regressions, we did quadratic regressions, we did cubic regressions, we did sinusoidal regressions, we did all kinds of regressions previously, right? That in AP Stats, we're going to do linear regressions. That's the only one we're going to do in AP Stats. We only do linear regressions. So it's the line of best fit. It describes how Y changes as X changes. We did that on, again, whatever day that was, I guess Friday. And this is what you need to know for sure, right? You guys have learned whenever we talked about a line of best fit or a line, we've always used Y is equal to MX plus B, okay? Well, in stats, we changed that just a little bit, okay? We changed it just a little bit. So the big thing I want you to know is it's not Y, it's Y with a hat on top of it, okay? It's Y with a hat on top of it. And I don't even like to put Y, I like to put context with a hat on top of it, okay? Context. Whenever you write the equation in this class, we don't write Y equals MX plus B, we write context, whatever it is, the height of the tree. Whatever this number is, or whatever this context is, the Y, and then we just put a hat on top of it. We'll talk about this hat in just a second, okay? Now, again, you guys are used to seeing MX plus B, okay? That's what we're used to seeing. In stats, they get rid of the A altogether. I'm sorry, the M altogether, and they'll just put it A. And so we'll use one of two. We don't care. If you want to do AX plus B, you can, or if you want to do A plus BX, you can. You can use either one. This is what I'm going to tell you to be careful about. And you guys being brilliant kids understand that if I'm using this one, B is the y-intercept. But if I'm using this one, B is the slope. A is the slope on this one, A is the y-intercept on this one. So just be aware of that. Okay, because they're going to ask you what the slope is. I don't want you to put down it's A here if you're using this one. Vice versa. Good enough of what I'm saying? Okay. Put this letter or the X also in context. Put the Y in the context and put the X in the context, whatever it is. Okay. How long you studied is your grade, and you'll put the hat on top of it. Okay. You'll put the hat on top of it. So context, context, context. Every time you write those, don't forget. Don't forget. That's one of your free response questions. What is the equation of the line? And so you'll need to put it in context. In this particular case, you should know that A is the y-intercept, B is the slope. Whatever's in front of your X or whatever's in front of that variable, of course, is the one that's the slope. And whatever the one is by itself, that is the y-intercept. Again, this is stuff you guys know forever, but I don't want you to miss it because it is so common sense, right? Okay, now let's talk about this y hat thing or this hat, okay? What that means is that is the predicted value. Y hat means predicted. It's not what y is. It's not the value of y, right? We have a scatter plot, okay? We have a scatter plot, and we're going to have a line. This is the value of y. That point is the value of y. I'm not using that point as y. I'm using this line for y. And so that line is not y, it's y hat, okay? So that's very, very, very important that you put that hat. If you don't put that hat, they're going to ding you for that. If you don't put it in context, they're going to ding you for that. If you put the wrong slope in the y-intercept, if you flip-flop those, they're going to ding you for that. So just remember those type things of what you'll get dinged for. It's not that hard, so I don't want you to miss it because of something like that simple. Okay, so let's talk a little bit more about the difference between that Y value and the Y hat value, or the predicted value. Okay, so we got a random sample of 16 used F-150 trucks. Okay, I went to autotrader.com and I just looked for F-150 trucks that were used. Found 16 of them. All 16 of them had different miles. All 16 of them were different prices. You probably could at least somewhat guess that as the miles increased, the price probably decreased. More than likely, not always, but typically as the miles increase, the more miles, the cheaper a vehicle is. And so I'm trying to see if there's a relationship between the miles driven and the price of the truck. Okay, with all that stuff? And so I put all that information in my calculator. I'll make sure you know how to do that later. But I put all the miles driven in my calculator and the price in my calculator, and I found the least squares regression line of that. But then I also plotted the points. Well, here was the equation of that least squares regression line. And again, that's how you'll see it. Price with a hat on top of it, because I'm predicting the price. 38,257 was my y-intercept. I just rounded it. It did not come out perfectly. Negative 0.1629 was the slope, miles driven. So it looks like the slope did go down. It was a negative correlation. And I found R when I did all that stuff. We'll talk about that as we go, but you already know that. Okay, with all this stuff, good? So I got my equation, I got my points, okay? Here is the scatter plot of it. Now I had a big gap of values that didn't fit, but you could see the price of the truck as the miles increased, the price of the truck decreased, and those are the points, and there's the equation of that line. Again, this is the actual Y value. This is the line. It's maybe hard for you guys to see this, but that's from the line, okay? Which is not the actual value, that's the predicted value. So that's why we don't put Y equals, that's why we put Y hat equals, okay? Can we predict the price of a F-150? Oh, I'm sorry, I passed this up. I'm sorry. Predict the price of a truck that had been driven 100,000 miles. So all I need to do with that 100,000 miles is simply plug it into the equation. Good enough? You guys did that forever. What is the value of Y when X is this? You plugged it in. Now that was a Y equals because that was the actual value of Y. This one's not. That's why we put Y hat. So I put 100,000 in there, multiply it by that 0.16, subtract it from that right there, and I'll get the price. And that price is 21,967. How are we going to get that wrong? Somebody's not going to put the hat. Somebody's not going to put a dollar sign. Good enough with all that stuff? But those of you that do those things, you're going to get your point for that question. Pretty easy. Yay? Okay. Then it says, can we predict the price of a Ford F-150 with 300,000 miles? So we'll plug in 300,000 miles. And when we plug in 300 miles, we get negative $10,613. Somebody's going to pay me $10,000 to get a truck. I'm in. Fair enough? So this didn't work because I saw several of it go, that doesn't make any sense at all. This is because that's this extrapolation. Extrapolation. When you're plugging in a number that doesn't fit with the data. Let me go back real quick. I'll give you the definition. Let's go back to my data. This is a truck, 70,000, right? 129,000. 131,000, 144,000. I don't have anything close to 300,000 miles. When I look at my scatter plot, this is 160,000 miles. I don't have anything close to 300,000 miles. And so this line is going to continue to keep going down. Fair enough with all that? Well, that doesn't make any sense. In fact, at some point, this thing probably quits going linear and it probably starts exponentiating or leveling out or doing something to that effect. Okay with all that? But we don't have any of that information, so I can't make that up. So it's called extrapolation because you're predicting outside the interval. I don't know that it's going to continue in that same trend or not. I don't know if it's going to continue in that same trend or not. I am predicting outside of that value. It's called extrapolation. We do it all the time in stats, guys. We extrapolate all the time because we're trying to predict into the future. Just sometimes we extrapolate wrong because it doesn't go in that trend. Probably happened somewhere around 2021 or 22 when a lot of predicting was going on and they weren't doing a very good job because nobody could sell anything, because nobody was buying anything, because we didn't have any products. Okay with extrapolation. Good with that word. Okay. Such predictions are not always accurate. They could be, not always. When you're extrapolating that much, not very good. Okay. Now, let's talk about a residual. Let's talk about a residual. In most cases, no line's going to hit every point exactly. I mean, in fact, not in most cases. I don't think I've ever seen a line hit the points exactly. Okay? Because we use our line to predict the Y, we make an error. We are predicting too high or we're predicting too low, right? Again, we have a scatter plot. We have a line that goes through it. This is the actual value. This is my predicted value. I predicted this one higher than it actually was. I predicted this one lower than it actually was. Because the Y value is what I'm getting, and the Y value is up and down. That's my vertical distance. Okay, with all that, good, right? That Y is my vertical. So they give me my errors in my vertical direction of the scatter plot. These vertical distances are called residuals. They're called residuals. And so that's a word we got to make sure we understand. It's the vertical distance, here it is. It's the vertical distance from the actual and the predicted. It's the vertical distance and the actual and the predicted. So I have a scatter plot and a line. This is the actual value. This is the predicted. That distance is the residual. That distance is the residual. We want those residuals to be what? Really, really small. Because if they are, then that means my line got really, really close to my values. If the residuals are really, really big, then I didn't get very close to those points. Yippee. Residual. Told you quite a few definitions. Quite a few definitions. Residual. It's the vertical difference between the actual point and the predicted point. I think I spelled that wrong. Okay, yippee, yippee, yo. Here we have those points. Here's my truck. This one's really close. I didn't miss that one hardly at all. As we got along through here, I started missing it pretty bad. I didn't miss it. This is not bad here. I guess it looks like maybe this is my worst one. Maybe this is my worst one. On the test, I'll probably have you draw or which point is the worst residual, which one is the best residual. Okay, with all that, good, yippee, yippee, yo. Data point regression lines, okay. Residual is the actual minus the predicted. The residual is the actual minus the predicted, or the Y minus the Y hat. Yes, there are negative residuals. Yes, there are positive residuals. And so you have to subtract it that way, okay? If my point is down here and my line is up here, this is the actual point. This is the predicted point. This is a negative residual. This is a negative residual. Here is a positive residual. Positive, the actual points are above. I'm predicting below. Negative, I'm predicting above the points below. Okay with all that? We do get negative residuals. We do get positive residuals. You have to subtract it the correct way. AP statistics. AP, AP. Don't do it wrong. Calculate and interpret the residual for the truck that was driven 7583. Well, I need two things. I got to find the predicted and I got to find the actual. So I'm going to find the actual first because it's the actual minus the predicted. It's the actual minus the predicted. So I got to figure out how far or how much, I'm sorry, a 7583 truck was. So I'm going to go to this table or I'm going to go to the graph or I'm going to go somewhere and I've got to figure out this 7583 truck cost $21,994. So it cost $29,994. 29,994. That was the actual cost of that truck. Now, I got to find the predicted cost of that truck. And the way to do that is I got to plug it into my equation. So I'm going to plug the 7583 into the miles driven, and I'll get the predicted value of that price. And so once I get that predicted value of that price after I plug it in, yippee yippee yo, there's the actual price. Here's the predicted price. After I plug it in, it costs $26,759. $26,759. $26,759. And so I'll subtract those two numbers and I will get a residual. It will definitely be positive. Okay, with all that, good. It has to be positive because that number on the left is bigger than the one on the right. Okay? Now, here's the interpretation. Most students don't have a problem with this. It's the interpretation. So, this is my predicted. This is my actual cost. I'm predicting it what? Less than the actual cost. That's how you interpret it. I am under predicting the price of this truck by whatever that number is. Let's find that number. 2675. No, that was that. Here's a residual. There it is. 4765. I am under predicting the price of that truck by 4765. No, I'm over predicting it. I'm backwards on this. Cuss. Nobody corrected me. This number's bigger, yes? That's the one I predicted, yes? The actual price is less than what I predicted. Good? So, I over predicted the price of this truck by 4765. First mistake this year. I had to do it on film. It's okay. I make a mistake once a year. Just I don't tell you when my years start. My year just started. Last year I made a lot of mistakes. I over predicted the price of this truck by 4765. Okay with all that? Good? I don't think about negatives or positive or anything else. I just think about where it is. I know that 26 is higher on the number line than 21. 26 is up here, 21's down here. This is the actual price. This is what I predicted. Well, if this price is above this one, and this is my predicted, then I must have over predicted the actual value of the price. Okay, so the interpretation is not that difficult. We just got to make sure we say it correctly. Luckily, I caught it. Now, they said it backwards than what I said it. It's okay to do it this way. The actual price of this truck is $47.65 less than the cost predicted. Okay with that? Okay. I also think I left out another word because I don't think I said the word predicted. You got to use the word predicted. So the predicted price, I over predicted the price. How about that? We got to use the word predicted in there somewhere, right? So interpret, there it is. The actual price of this truck is $47 less than the cost predicted. Or you can flip-flop that. I predicted it higher than what the actual cost was. You can say it either way. It says the same thing. I don't care which way you say it. Just don't say it wrong like I did the first time. Everybody good with that? Residual. You got to understand residuals and know what they are. It's the vertical distance. It's the vertical distance because it's the y values, and y's are vertical. They're up and down. Okay? 2 more interpretations. I need to interpret the slope. I need to interpret the slope. You already know from however many years ago, slope is rise over run. It's rise over run, or it may be fall over run, but it's rise or fall over run, okay? And we know that rise is the y values and run are the x values. And you guys are somewhat used to seeing like maybe 3/4 of a slope. In statistics, it's always a decimal. It's always a decimal. So it's always 0.16, whatever it was, negative. It's always over 1. Because this is always a decimal, so it's over 1. You don't need to switch all this stuff to make it like 16 over 100, or just leave it over 1. Leave it a decimal over 1. Okay? So this is going to rise or fall, depending on if it's positive or negative. You know it's rise over run. So it's either going to rise or fall. And then we put it in the context. So in this particular case, this is the y value, which is the price of the truck. So I would say the price of the truck goes down 16 cents every 1 mile. I just go back to what you guys learned in 7th and 8th grade about the rise over run and the slope and the rise of the y values and the run of the x values. And you're always going to run one value in this class because it's always going to be 1. And running is always going to be your x. So you're always going to run 1, whatever the x value is. And you're always going to rise or fall. If it's positive, it's a rise. If it's a negative, it's going to be a fall. This is one of your multiple choice questions. And I can only mix this up so many ways. Right? I can switch an x and a y. I can switch the numbers. And I can switch the positives and the negatives. But most students get this right because they understand slope. And they understand that we're either going up or we're going down, and that's the y value. Up or down is the y value. And you put it in the context, so whatever the y variable is. And then we're always running 1 mile. Or run whatever the x variable is, because the x is always left or right. Good enough? This is what they're going to say. The predicted y. Again, this is what you got to make sure you say. The predicted. Yeah, predicted, because that's the y hat. And that's the word they're going to be looking for. And it goes up or down depending on if the slope is positive or negative. If it's positive, it's going up. If it's negative, it's going down. And then the context. So it goes up or down by whatever that is for every 1 unit in x, because x is always going to be 1 unit. In this particular case, it was 1 mile. It might be 1 feet. It might be 1 year. It might be 1 second. But they are going to for sure look for the word predicted. They're going to look for that word predicted. The predicted y, and those I put y in little quotes because I'm talking about context. So the predicted value of the truck goes down by 0.16 for every mile driven. Yes, no? Not that bad. Most of this you know. We just got to make sure we know. You explain what you do know. Right? You've known forever the slope is rise over run. Up, over, up, over, up, over. Or down, over, down, over, down, over. This particular one was down over, down over, down over. Down 0.16 over 1. Down 16 cents over 1 mile. Predicted. The predicted is the word you might forget. Don't. And then the y-intercept, they're going to want that also. Oh, remember rise over run. Rise is the y variable. Run is the x variable. The run will always be 1 in AP stats. And then if we're going to interpret the y-intercept is what? When x is 0, right? When x is 0, that's the y-intercept. Sometimes that means nothing. Sometimes that value is extrapolated. So just be careful of that. In this truck data, I think 0 is extrapolated because I don't think I have any truck with 0 miles. However, we'll show you in a second what it would do, right? The predicted value, so again, the predicted value of y when x is 0. And again, it's context. They don't ask the y-intercept that much. They don't ask a whole lot about the y-intercept. Most of the time, it doesn't mean anything to us. That's kind of like my initial value, my starting value, okay? In most instances, it's extrapolated, so just be careful about that, okay? Most instances extrapolated, so just be careful. Too fast, pencils? You'll need something? What do you need? Go back something? Where? There? Y'all are really talkative today. Sarcasm. Don't have any problem talking during when you get into class. No, I can't. I got me filming. I was going to get my stick. But I'm filming. As soon as I hit stop, I'm getting my stick. Whee! Click. Here's my truck. Here's the y-intercept. Here's the slope. Interpret the slope. We've said this like 4 times already, right? The predicted price of the truck goes down 16.29 if you want to, but 16 cents for every mile driven. How'd they say it? The predicted price of a used F-150 goes down by 16 cents for every additional mile that the truck has been driven. Good enough? And then if we want to interpret the y-intercept, does it have any meaning in this context? If so, interpret it. So that would be what? 38,257. First of all, I don't think you can have a used truck with 0 miles. However, if you have a truck with 0 miles, I guess it's going to cost 38,257. That's not too outlandish of a price. Good enough with all that stuff? It kind of makes sense, except for the 0 miles being a used truck. So that's where they say the predicted price has been driven 0 miles. The y-intercept does have meaning, as it's possible to have a car driven 0 miles. I just don't think you can have a used one driven 0 miles. If the price was something like negative 280, yeah, we'd have issues with that number for sure. Or if the price was 1.8 million, probably have issues with that number. Yay? Okay, here's where I tell you, make sure to include the word predicted. It says or equivalent. I don't know what else you can use besides predicted. Okay, so make sure you use that. Beautiful. Okay, y'all see that scatter plot? Strong, negative, linear association. Good. Beautiful. Line of best fit. We're going to try to hit as many points as we can. If we can't, we're going to try to get as many close as we can. Probably somewhere not bad. I don't know. Somebody else may draw it like this. Not bad. Good. All these are lines that work. We only want one line. We only want one. There are many different lines we can use to model the association of a scatter plot. There are many different ones. A good regression line makes the residuals as small as possible. The regression line we prefer to use is the one that minimizes the sum of the squared of the residuals. We're going to call it a least squares regression line. That's what our line of best fit is called. The least squares regression line. You can abbreviate it LSRL if you want to. It's okay. That is the best line of fit. It is one that minimizes the sum of the squared of the residuals. You know what a residual is. That's A minus, or I'm sorry, that's Y minus Y hat. That's a residual. That is the actual cost or the actual value minus the predicted value. We would like for that value to be pretty small. Whatever that distance is, I'm going to square that distance. It's kind of like we would do the standard deviation. Remember, the standard deviation was x minus x bar. And then we squared each one of those because x minus x bar, if I added all those up, it was 0. Well, guess what happens if I add up all the residuals? I'm going to get 0. So they're going to square those residuals. So the sum of the square of the residuals is small as possible. As small as possible. If the sum of the squares of the residual over here is this value, and the sum of the squares of the residuals over here is this value. If this number is bigger than this one, then this one has a better line of fit. Watch. I get to play game. Maybe. Scatter plot. What's the correlation between those 2 points? Positive. What's the number? Has to be 1, right? Positive 1, because you can draw a line right through those 2 points. And if I put another one really close to it, I'm probably also still getting 1. Still at 1. Now I'm starting to not get 1 because I'm starting to get points that aren't right in a straight line. But notice I'm at 0.92, right? Now what happens if I put a line on that same type thing? It's going to either stay 0.91 or maybe even get bigger. And what happens if I put one nowhere close to that? It's going to get smaller. 0.5. Like it dropped from 0.92 to 0.5 just from that 1 point. If I would have put that point right through here, 0.9, 0.91, I can't get a 2 again. Yippee? Good with all this stuff? Beautiful. Okay, I'm going to draw a line. Where are you at? There you are. That's a horizontal line. That's horrible. Let's put a slant to it. Uh-oh. Should have moved it down here, I guess. Ooh. Yeah. Not bad. There's the residuals. You can't really, it may be hard to see, but those are the vertical distances between them. And if I square all those residuals, I'm going to get some number. I don't like this website, but the one that I used to use, I can't find anymore. But they would actually tell me what the sum of the squares of the residuals was. Good enough with all that stuff? Here's my question, and here's a question you're going to see. Ooh, boy, I was close. I was real close. A little bit slope is a little bit off there. The sum of the squares of the residuals for this red line is what compared to the sum of the residuals for the blue line? Less, more, the same. Has to be less because this is the least squares regression line. I can't make one smaller than this one. Any other one is going to be bigger than this one. Okay? Got to understand that. You have to understand that. That's why it's called that. Again, you can't tell the difference between that blue and, or sorry, that red and that blue. But I'm telling you, it's worse. And I know that because this is the line of best fit. And that's what the least squares regression line is. Okay? I can start switching this thing over here and you'll see that jump all the way over there because there's no way that's the line of best fit. Yay, good, beautiful. I love playing. This is a good little game. Funsies. Okay, go away. Go away. All right. Here's free response question. I'm going to add a point to that scatter plot. Okay with that? So I may have you add one, I may have you take away one. That's what that homework question was with that hot dog kind of, right? You had that hot dog down at that bottom that didn't fit the data at all. What did it do with it, right? So I'm going to take one of these little points out of this little bucket and I'm going to put it on that line, or I'm going to put it, on that scatter plot, and I'm going to put it really close to all these other points. Okay with that? I'm going to put it right in the middle, like right with all those other points. So here's my question. When I add that, will the slope of that line increase, decrease, stay the same? Will the y-intercept increase, decrease, stay the same? Will the correlation increase, decrease, stay the same? And so those are things you need to know, that if I add a point to that graph, depending on where I add it, what it's going to do to the slope and what it's going to do to the y-intercept and what it's going to do to the correlation. I'm going to put it right on the line. I'm going to try to. It's not real easy to do because as I move it, the line moves. Did it move? Increase, decrease, stay the same? Stay the same. If I put it right on it, it's going to stay close to the same. If I put it up here, it's going to do what to, if I move it up, if I add one up here, I'll move this point up here. Is the slope going to increase, decrease, or stay the same? Careful, some of us get backwards on this. It's going to decrease. It's going to almost make it horizontal. Okay? If I move it down, it's going to increase it. And my correlation coefficient is going to get worse because you got a point that doesn't fit the data as well. 0.89. Okay with all that? Oop, I didn't even know where it went. Where'd it go? Did I remove it all the way? Over here. If I move it up, it's going to increase it. If I add it down, it's going to decrease the slope. If that decreases the slope, it's going to do what to my y-intercept? Increase the y-intercept. So those are things you kind of have to recognize from doing this. Be careful. I go through this every year and still I get about 90% miss the question on the test. Because I do a good job of tricking you. I made R negative now. I made the slope negative. And I got a bunch of points through there. Kind of interesting, huh? Yeah, just cool. This is a little game I like to play. Clear, watch this. I have data. Height versus shoe size. Life expectancy of TVs. Holy cow. Average number of people per TV. Huh. 600. Temperature versus cricket chirps. Oh, well. Y'all are done. I think I'm done. Oh, and I'm not done. I got to show you one other thing. Oh, so here's the sum of the squares of the residuals. That's 461 million. Holy cow. I can't get one smaller than that. No, because these numbers are what? Ginormous. Right? If the residual, what was that? That one residual was like 4,000, right? So you square that 4,000, you already got 16,000. That was just one residual. So they're going to add up fairly quickly, okay? Something that you guys need to know is how to find the least squares regression line, okay? So I know that's been a while for many of you guys. Where is my calculator? Oh, here it is. You can do it on Desmos. You can use TI. Either one will make the least squares regression line, okay? Either one will do this. I'm assuming, I'm getting bad assumption, I think, but I know you guys did this a lot in pre-cal, so it's the same type deal, okay? So let's talk about this calculator for just a little bit. Stat edit. Stat edit. Stat edit will put your data in there. Okay, stat edit will put your data in there. Anytime you have data that you need to put in your calculator, it's stat edit. Okay, this sorts at ascending. I don't think I've ever done that. That sorts at descending, and I don't think I've ever done that. If you want to clear a list, this will clear a list, and then we'll set up an editor. You may have to set up an editor every once in a while. Let me show you that part. Okay, so when I do stat edit, you should see L1, 2, 3, 4, 5, and 6. And I don't put anything in 3, 4, 5, and 6 unless if I just absolutely have to. Okay? I'll do it every once in a while because I want to compare L1 or first period to second period and third period. But I try not to ever put anything in 3, 4, 5, and 6. I want everything in 1 and 2. And sometimes, every once in a while, like 2 gets erased, or 4 goes away, or maybe even 1 goes away. And so when you say where'd they all go, that's when you do the setup editor. So you go stat setup editor, number 5, and you hit enter and it says done, and you don't have a clue what it did, but when I hit stat edit, that put 1, 2, 3, 4, 5, 6 like it's supposed to. Okay? So if you're ever missing 1, 2, 3, 4, 5, or 6 or something, set up the editor. And you want to remove one of them, like L3, the best way to do it is stat clear a list, and you tell it which one you want it to clear. And here's L1, it's blue. L1, L2, L3, L4, L5, L6. So if I want to clear L4, I can do that. If you want to clear them all, you might as well hit second plus, because that's where all your memory is. And there's where you can clear all the lists if you want to. Okay, stat edit. So you put the data in there. Once the data's in there and you need to find the least squares regression line, you can do that, okay? First thing you might want to do also, though, is look at the scatter plot. So here's how you look at the scatter plot. You hit second y equals, and you turn your scatter plot on. On. Here's plot 1, here's plot 2, here's plot 3. I'm on plot 1. I'm going to turn it on, and there's the scatter plot, the very first one. Your X list is coming from L1. Your Y list is coming from L2. If you put it somewhere else, that's where you need to tell it to change it to those others. And when you hit graph, you're not going to see it. Well, I'm going to see it. You won't see it because you'll be 10, 10, 10, 10. So you hit zoom 9. Every time you're in this class, anytime you're trying to graph anything, you want to zoom 9 it. And that will draw your scatter plot. You can see that it's quadratic because I was doing pre-cal stuff with it. Yippee-yo, good with all that stuff. Now, if you want to find this line of best fit, which you will have to do for your homework tonight, stat, edit, put your data in there. Once it's in there, it's good. You have 2 options. I'll tell you which one's better. Calc will find it. This is what you guys did in pre-cal. You would go down to where it says lin reg. Notice that you have this lin reg, which is the AX plus B, and you have another lin reg, which is the A plus BX. You can use either one. I don't care. Just remember that if I use this one, A is the slope. And if I use this one, B is the slope. Just remember that. We're not going to do quad regs or cube regs, or we're not going to do any other regs. We're going to do lin regs. What if it's not linear? That's the section we're not doing. That's 3.3. We're doing it. But so you do lin reg. But I don't use either one of these two. And there's a reason why. Here, let me just use 4 real quick. I'll use 4. Here's L1. Here's L2. Frequency, store it. I don't care. Calculate it. Boom. There's a least squares regression line. You can see it gives me A and it gives me B. In this particular case, A is my slope and B is my y-intercept. Good? Again, I don't use those yet. Stat, calc, go over to tests. This is what you're going to use all second semester. So just go over to tests. It's not a Z, it's not a T. You're at one of these you're going to see lin reg. Actually, 2 of these you're going to see lin reg. They're at the bottom. There. Oh, I should have went up. Lin reg T test. Lin reg T. Oh, that says int. Sorry, T test, T int. Use either one. They don't care. Just use either one. They'll both do the same thing. Okay. So I'll do the test. Now it says X list, Y list. Then it's asking me a frequency. And it's asking me something else. I have no clue what that is. That's second semester. And then I have nothing. Calculate. It gives me something I don't have a clue what it is. It gives me something else I don't have a clue what it is. It gives me something else I don't have a clue what it is. It gives me something else I don't have a clue what it is. Finally, it gives me A. And A is the y-intercept. And it gives me B, which is the slope. But look what else it gives me down below that. R. And so later on, we'll need to know R is negative 0.14. Well, you saw that was a quadratic. You knew it was not going to fit very well. That R helps validate. It's not a very good line. Okay? We're going to use R squared later. We're going to use S later. And if you don't do this, you won't see R squared, S, or R. Good with all that stuff. So just kind of get in the habit of doing it. Just to show you that if it doesn't matter which one you do, I'll do the int one. It's still L1, L2 frequency. It's asking for something else. I don't care. It doesn't matter. Don't care. Just calculate. It's going to give me some different information. It gives me something that I don't know what that is. And oh, there's B. There's the slope. DF. I don't know what that is. There's S. There's A. There's R squared, and there's R. So it gives me all the information. Just gives it to me in a little bit different order. I don't care because tonight all they're going to want is the slope and the y-intercept. And so you can get that from any of the 4 regs. The lin reg AXB or the lin reg BXA or the lin reg T test or the lin reg T int. Those all will give you the slope and the y-intercept. Just Thursday, we're going to need R and we're going to need R squared, and S. Good?